silent, neutral, and affective mutations. So, what is a silent mutation? A silent mutation is one where there is a change in the DNA base sequence, but the amino acids coded stays the same, so there is like no effect. But however, not all the mutations are silent. Let's say for instance, insertion and deletion are certainly not silent. There are many point mutations that do actually change the structure of the protein, but the same polypeptides are produced. So there isn't much of an effect on point mutation, which is also called, substitution mutation. So if we have a look here, what is a point mutation? Affecting only one or very few nucleotides in a gene sequence, kind of similar to substitution mutation. So main point mutation takes place in the body DNA, in which changes structure of the protein. Even though the structure of protein is different, but it still produces the same polypeptide. So there isn't really much of a big effect. It's not a killer. There are neutral mutations as well, as long as differentiation gives the organism no particular advantages or disadvantages. So neutral mutations, there are mutations, but does not give it any advantage or disadvantage. So some mutations do change the protein structure and actually gives the organism an advantage or disadvantage. These are known as positive and negative mutations. So as long as a point mutation has not got any advantage or disadvantage, then it would not change the protein structure. So here we have a butterfly. This butterfly is coded in this sort of sequence. The butterfly goes through point mutation, and the change of the nucleotide is beneficial and therefore changes the shape of the protein structure. So this change has been beneficial and it changes the structure. Now the butterfly looks like this. So let's do this in a more effective way, in a more clear and understanding way. So if we have a silent mutation, a silent mutation. This silent mutation is when there's a change in one of the DNA base pair. If I had a base pair here, it's a long sequence, and I had one little change here, and a few little change here, I had a change here. This could, sometimes this is a point mutation. This could be a it could be a mutation, it's a mutation, but it still produces the same amino acid in this case. Yep. So it still produces the same amino acid. So there's no effect. But however, not all mutations are silent. Not all of them are, these big word, silent. Not all of them are silent, to be honest. There are many point mutations that do take place. But however, not all mutations are silent. So if there's a thing called point mutation, if we have here and a section of it, so if I say this little section has been changed, so it may affect the structure, but the protein structure is different. So the protein structure is different. It still produces same polypeptide. That's the thing with this. So there's no big of deal with it. So there, as you know, there's no big effect. No big effect. No big effect. So if I rub all of that out and go to some mutation, how they affect us. So rub all of that out, and if we look here, the neutral mutations. So it's a neutral mutation. What is this? A neutral. This is when there is no advantages or disadvantages. So there's none of these. There is none of these ish going on. But if some of these ish are going on, so some of these ish are going on, it is no longer called a neutral mutation, it causes an effect. And therefore it does change the polypeptide, like we're shown here. If the point mutation has advantage, disadvantage, it changes the structure of the protein.